Okay, so we have a sharp vertical impulse is given to inform solid sphere. Good. So a sharp vertical impulse is given to inform solid sphere of mass and and radius r. So if you give impulse j, it will create impulse here. J. Okay. Now this force, this impulse cannot create the horizontal velocity, right? But this impulse will create impulsive, you can say, torque about this point, center. And so it can create omega like this. So the tendency of the bottom is to go right or left.
Right.
The tendency of bottom is to go right. So the friction will act
Left.
the impulse of friction will act like this. So impulse by the surface is resultant of these two, right?
Yes.
It is not the same as this, right? So option A is incorrect.
No, they've given ABD. ABC, sorry.
No, that's correct because they will written perpendicular to
the
surface. That
surface.
is okay. That is okay. Net is not equal. So in that way it is equal. That's correct. Minimum value of coefficient friction between sphere and surface to avoid slipping. So this JF, the moment because the tendency will create a VCM.
Yes. And that should be equal to omega, right?
Correct. So the net torque about the center will be J times
We have to take that angle.
R cos
cos
37
37. Correct.
minus
R.
JF times how much? R.
R.
And net torque, impulsive frequency torque or impulse of angular impulse of the system is equals to ICM. ICM is how much? It's a solid sphere, no?
Yes, 2/5.
Into omega.
Correct. And omega R must be equal to
And
VCM.
JF equals to MVC.
I said I got my mistake.
Okay. So you missed this point?
No, actually I took the wrong value of cos 37.
Okay. Okay, so I think you can do this. And then use VCM equals to omega for the no slipping condition. Right?
That I did the same thing, but I just took a mistake. So I wasn't getting the right numerical value.
Okay. So now you can solve, right? Next is again conservation of angular momentum.
Yeah, but it is about different things.
Let me read it. Uniform rod of length L. Let me draw the rod first. Of mass M length, right?
Yes.
And M is a point. N is a point.
Yes.
And this
Q is
length
also point.
L by 4 and Q is
L by 6. And there are two other stationary points outside the wire.
1, 2. Okay. Now let me do it. So, so if you look carefully, there is no external force, right? If you take the system, then there is no external force because these two are going to collide, right? So if you take this entire thing in the system, what is the external force? 0. And because the external force is 0, so the angular momentum is going to be conserved about every point, right? So the first answer will be all. Isn't it? Next part is linear momentum. Linear momentum conserved from points.
Here, actually, even they have given answer as PRST only. They are not giving Q.
PRS.
They have given answer as PRST, not Q.
I don't think. Just let me look. No, it is conserved out every point. Why it is only one
That's
point?
why I also did the same thing, but then I got it wrong. So
No. All will be correct. So how we can ignore the Q point? Not possible.
yes, because PQRST, all of them will be conserved, right?
Yeah, every point is
Every
conserved
point,
in this space.
then that is correct.
That is mistake. Linear momentum conserved from point.
Only ST, right?
Linear momentum. So linear momentum is conserved in the ground frame, the frame which is at rest.
So OP, right?
OP, yes.
I did the same thing, but they are giving PST as answer. Means QOP. But Q won't be possible, right?
No, that's not possible. So if Q is answered, then N is also answered.
You see, that's so correct,
No, wait. Q, yeah. Q is the answer. Correct.
How?
Q becomes the ICR.
But we don't
But
have.
is M the center point?
No, they are not. They haven't told us anything about that, right?
Yeah, that's a mistake. If M is the center point, then L/6 is the point
So
of
that's
ICR.
why what I did now, I thought that ICM be anywhere on the rod. So like for us, QMN are in motion, right?
No. The idea is if M is the midpoint, then because rod is informed, so center mass will be at the center only. But they
we
need
don't
to
know
mention.
where M is, right?
Correct. It is not mentioned. So this diagram is incorrect.
Okay.
So the idea is if M is the midpoint, then L/6 is the ICR actually for any rod and particle collision. And how we do this, if you remember, I'll just prove this point. So the impulse will act like this, correct? And this impulse will create a MVCM, right? The momentum. And J equals to MVCM. And it will create omega like this. So JL/2 equals to ICM omega. And therefore, if you just substitute the 2 here, MVCM into L/2 equals to ICM is ml square by 12 into 6 into omega. So this gets cancelled, this gets cancelled, this is 6. So VCM equals to omega L/6. So L/6 is the point at which the VCM and omega L/6 will exactly equal and opposite, right? Hello. Yes or no?
Yes, sir.
So this point is at rest because this is at rest, so it will act as inertial point. So we can conserve about these 3 points.
Okay.
But this is only true when M is midpoint.
But they have not given, so I guess we
Yeah,
can't
so
take
this-
that, right?
Yeah, so
Or
that's
I
why,
think one of the lines from the question would be missing.
yeah, something is missing. And so of course, this
Understood.
question is having the error actually. But anyway, that's the idea. You should know this.
Yes, yes, yes.
So the C point says is speed of point Q. Just now everything is mysterious because I know the answer will
Understood.
come. Answer will come if you take M as midpoint. Then answer will come. All answer
Understood,
will
understood. But
Okay.
yes.
come. Then leave this question. The rest is okay.
Done.
Okay.
Uh,
Yes, yes.
Nothing.
But in your question, do you have any mechanics question?
So just a second.
Well, then I'll solve that also. Sixth question was 6, right?
It's a fluid. Yes, I'm mechanics related.
So a regular tetrahedron is completely immersed in water of density rho and its bottom surface horizontal at a depth of h. Edge of tetrahedron is A. The net force by the liquid on all the side faces of tetrahedron is. Oh, that's easy. So what you need to know is some mathematics. So it's very easy question. So how many you know the volume of tetrahedron? Anyone knows? Volume of tetrahedron? Any idea? No idea. So I think all sides are equal. This is base is equilateral triangle, right?
Yes.
Yes.
This is also a draw a perpendicular from the top to the center. And we can find this centroid, right? So this is 30 degree.
Yes.
R cos 30 is A by 2. It's a bit of maths. So R is A by root 3, okay? And now we can find the Pythagoras H. H is how much? Root 2 by 3 like this, okay? And volume of tetrahedron is how much? Anyone knows volume formula? From vectors in 3D?
It's scalar triple product.
Yeah. So A 1/6 of area of the base into height.
1/6. Yes.
So root 3 by 4 A square.
Square into root of 2 by 3 into it.
This one. So how much? Am I right? This is okay. So I may be wrong with the volume, but I think this is the answer. I mean, this is the formula, which I don't remember. Okay. So that is exactly the okay. Anyway, this is easy only. This angle is how much? Okay, that you need to find, which is same thing. So the vertical height becomes A sin theta. Theta will get the again same way. But anyway, the triple is scalar product gives the volume of a cuboid, parallel pipe.
Parallel pipe.
And this will become 1/6 of this. For tetrahedron, right?
Yeah.
Now we are done. We are done. So now the bottom is at a depth of H. So what is the pressure here? Rho GH. Not this. This H is different. Don't get confused. So pressure is rho GH. What is the area? So rho GH into pi. Sorry. Root 3 by 4 A square. Right?
Yes.
This is the force upward. What is the downward force which we don't know? Let's call F down. And the difference of up and down is called buoyancy, which is V rho G. So F on the all side surfaces how much? Rho GH root 3 by 4 A square minus rho G into volume, which we got as AQ by 12. So rho G A square common root 3 H by 4 minus. I can put something in it. Okay. 4. Yeah, check the answer. Do we have any answer like this? Or just I'll check the volume of a tetrahedron because that is the formula which I might be
Sir,
missing.
I guess we have mistaken the guys. It's fine.
Volume
It's a cube root 2 by 12.
AQ root 2 by 12.
Yes.
Is it 1/3?
No, I'm telling the volume.
So it means it is 1/3, no? The formula becomes area of the base into height.
Yes.
1/3, no?
Yes, sir.
Okay. So this will become 6 root 2, right? Correct?
Yes.
No, this will become 12. So this will, okay, let me write this. So how much is the answer? Root 2 AQ by 12, right?
Yes.
Now check the answer. Is it matching? Rho G A square by 12 we can take common. So it is 3 root 3 H minus root 2A.
Yes, sir, it's matching.
Oh, so how I'm mistake in the tetrahedron. Half A square sine 16. Which is this is correct. Then yeah, it's like a cone only. Cone formula is 1 by 3 into area of the base into height, right? Yeah.
Yes.
So volume of regular tetrahedron. Yeah, it is AQ by 6 root 2, which means root 2 AQ by 12. Yeah, so that is the formula only. The rest is easy. The concept, other concept is simple.
Yes, sir.
Force exerted by the liquid on the bottom. Bottom is what? Bottom to we know the answer. And net force is everything will be known. This is net force. Okay.
Yes, sir.
So I think all are done. Yeah.
Sir,
Any other question?
for finding for individual walls, we would have divided it by 3.
Yeah, by 3.
Okay.
Because it's a symmetricity, so you can use that idea of symmetricity.
Sir, what if they are like different lengths?
For different length, this is always true. For in fact, any shape. So you just need to know the volume. That's it.
Okay.
Yeah. So
Then the force would be divided, like would be in the proportion to the length ka ratio, right?
no.
That force
Like
on individual walls.
if the base is horizontal, we can write this force always. The downward force you can just write as some x variable, and the difference is always zero. That is the basic definition of buoyancy.
Yes.
So we have done many questions like this in the notes also.
Sir, I'm talking about force on walls. So
If
that
it is not symmetrical, then you can't say about individual. You can say about the all total.
total, we can just subtract it. Okay.
Yeah. The next is. Yeah, the rest is not from the mechanics, right? We can leave this.
That one is from kinetics.
Which one? Tell me.
Question number 3. A stream of particles, each of mass m. Just before that question.
Yeah. This is from diffraction.
Oh, okay.
So when you have a hole of diameter d naught, and if you think as a particle with a momentum mv, so the d probability is how much?
H by P.
Now, if you do like this, so it will turn the first minima will occur at angle theta such that so the opening sine theta becomes the first minima occurs at lambda only. So d naught, and you can say this as y by this separation. What is the separation? L.
L capital.
So y becomes lambda L by d naught. So the what they ask me? This height, na? From center to this height, right?
No, they're asking. Diameter. Yes.
Diameter.
Distance.
Diameter is this much.
Entire.
Is 2y, right? 2y. And now it means d naught plus y 2y. Because this is y here. Symmetricity.
Yes.
And this is d naught, so d naught plus 2y, right?
Okay.
And y is lambda L by d naught. And lambda is how much? H by mv naught.
So actually they have used that H dash. So that is H by 4 pi, right?
No. Let's ignore that part. It's H only.
Acha, okay.
So A is matching, no?
Yes, A is matching.
It by mistake, it is not HY, it is H only.
Okay, sir. Actually, seeing that, I was thinking using that uncertainty principles.
Okay, so basically it's the uncertainty only. So diffraction, from using diffraction, we derive the uncertainty.
Okay.
So this should be the answer, but okay, I'll just check with the delta x h by 4 pi, no? Like more than equals to.
Greater than equal.
That's why they have written h bar by 2, right? H by 2 pi is called h bar.
Actually, it's H by 2 pi. I was taking as H by.
And delta py, delta px. Just you can say here. Just a minute. I can prove that. Yeah. So in the meantime, you reach L, you will travel upward. But this will become. Just check the answer. I think it's a mistake only. H bar should not be there.
Okay.
If answer is A, then it is H only.
Sir, answer is A. So,
Okay. Any other question?
No, sir, those are not from mechanics.
Yeah. Yes. So the first thing is called, we'll start with something very unique. Optical length. So of course we have something called geometrical length and we have something called optical length. So we'll start with this idea only. So let's say we have a medium in which the light is propagating this way and t is the length of medium. So we know in vacuum the speed of light is c, and if you enter a medium of a refractive index mu, what is the new speed? Because that's the definition of mu, c by v. So speed of light in a vacuum upon medium is called mu, right? By definition. Yes or no?
Yes,
Is
sir.
this part clear? So how much time it will take to cross the medium? Time taken to cross the medium is how much?
Length by
Distance
V.
upon speed. Okay.
Yes.
And what is speed here? Now, in the same time, if you would have traveled in space, free space, how much you would have traveled? So delta x in free space or vacuum, or even we can take air also, or approximate answer.
T by C.
So you would have traveled ct.
Yes, sir, distance is C, yes.
But if you look ct, it is mu t actually. So this is the first way of thinking about the optical path. So this medium of length t is optically equivalent of vacuum of length mu t. Now, why it is required? So when we calculate the interference or something, and when the light passes through medium, air, and so many things, because of the difference of medium, we try to convert everything into one medium, that is air equivalent or vacuum equivalent. Then only we can compare things, right? Hello, yes or no? Am I audible?
Yes.
Hello,
Yes,
guys.
sir.
Okay. So the other way of thinking, the second perspective is, if we have a wave of wavelength lambda not in air or vacuum. Okay. So if you have a wave of wavelength lambda naught which is in air or vacuum, the moment you enter a medium of a refractive index mu, what is the new wavelength? So will it shrink or will it expand? Because wavelength is defined as speed of wave into time period. Okay. Which is like v by frequency. No, not this time. This is the time period of the oscillational wave. And frequency is a property of source.
Source.
So as you enter the medium, f remains same. F is f only. But the c becomes v. Now, in order to maintain the f, so f is constant, so we can say v upon lambda equals to c upon lambda naught. Hello, yes or no?
Yes, sir.
So you can see clearly that lambda is how much? Lambda naught times v by c. And what is C by V here? Refractive index. So which means it will shrink actually, because in a medium you can travel very slow. So because your time period is same, but you're moving slowly. So in one time period, how much will travel? Less or more? Less only, right?
Yes.
So technically, the wavelength is the separation between 2 points having similar phase, right? The minimum distance.
Yes.
And similar phase happens when we spend one time period. Because the wave will repeat the process after one time period. Yes or no?
Yes, sir. Yes, sir.
So the idea is if you have a medium of length t, and if you, the moment a wave enters inside, the wavelength becomes small, right? So lambda not becomes lambda. So how many wavelengths we can accommodate in the same length? So the number of wavelengths that we can accommodate in medium of length t is how much? T by lambda, correct?
Yes.
So this is the count. So let's call this count as length. Now, if the same count, if I want to keep in air, so how much length of air we need to keep the same count? So n lambda naught, correct?
Yes.
So the equivalent medium length, let's call L optical. So what is the optical length? N lambda naught. What is n, by the way?
E by lambda.
And we know that lambda itself is lambda not by mu. So there are two perspectives. One is the time perspective, other is the count of wavelength. So when we say two paths are optically equivalent, so two paths are said to be optically equivalent if they contain equal number of wavelengths. Hello. It is clear?
Yes, sir. Yes.
So two paths are equivalent only when they have equal number of.
Wavelengths accommodate.
Very good. So of course I'll come to ray optics, don't worry. But because it's easy to go through the wave first, then ray. Because I'm teaching in a very different format today, very unique way. You'll come to know why I'm doing this. So imagine a regular YDC. And we have a symmetrical source. And then you put a transparent thin film. How thin? It's in micrometer. For the sake of writing, I'm doing it with it. And thickness is G and RI is mu. Okay. So if I go from here, let's say my aim is to reach the center. Now, which path will have more number of wavelengths, upper or below path?
Below.
More number of wavelengths. Geometrically, both paths are equivalent. Yes or no?
Yes.
But optically, which path is bigger?
The upper one.
That is obvious, no? See, number of wavelengths from here to here is same as here to here because of symmetricity. Same medium, same length, same number of count of wavelength. Yes or no?
Yes.
And anything from here to here, and if I take the equivalent air here, just to differentiate, and whatever is from here to here, both are again same.
Yes.
But we know T thickness of medium will act as mu T length optically.
Ah,
And also because it's a medium, so the wavelength will shrink and it can accommodate a more number, right? Which you don't understand.
Yes, sir.
But the T thickness of air will contain T only, right? So the
T only.
optical length is this much only. So what is the difference of optical length of two paths?
Mu minus
Mu
20.
Now everything is equivalent. This is the extra length which you don't see. So visually, what we think as equal distance is not optically equal. So we have this much extra length, right? So reaching at the central maxima, or sorry, not reaching the center of the screen, which is symmetrically placed, which path will take or will keep more number of wavelengths compared to the other path?
The upper one will have more wavelength.
Do you all realize this? Yes or no?
sir, mu is greater than 1.
Of course, mu is more than one. What you are saying?
Okay.
Mu is refractive index. Is mu less than one in general?
No, not in general.
So mu is more than one only, no?
Yes, yes, yes.
The definition of mu is what? C by V.
C by V.
So can we have more than value of V more than C?
No, 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 no.
So now there are many ways of thinking. The upper path is extra by what value? Compared to the lower path.
Mu minus 1.
So if the lower will contain, let's say, n number of wavelengths or n lower, what is the upper path will contain? Can you guess? So n upper will be n lower plus some value, right? Hello.
Yes.
How much extra? How to get the extra value?
Extra path length divided by number of wavelength.
Wavelength in air, in vacuum. Because we are converting everything into vacuum equivalent. Okay.
Yes, sir.
So in wave optics, what really matters is the difference, not the, see, whatever is equal, we cancel out. We only look for the extra value. So let's say the delta n, which is nu minus nl, is how much? So this could be a fraction also. This could be integer also. So let's say this is a number called 1. What does it mean? If it is exactly 1. So the two paths will differ by one wavelength.
Exactly. So both maxima will coincide, minima will coincide.
Yeah. So after one wavelength, it means you will be again in the same sync, right?
Yeah, same phase.
Same phase. Correct. Which means the center will be again maxima.
Yes.
Because the paths are equal, so it means you're superposing in the same phase. So peak will meet the peak, trough will meet the trough all the time. So what we'll get is the maxima. Yes or no?
Yes, sir.
Imagine if the number is 2. What will you get?
Still maximum.
Again, 3. Maxima for, see, if the difference is the integral number of wavelength, it means you are again coinciding, right?
Yes.
If I draw something here, one less, and now just I increase one more. So everything is in phase, you can see. If I increase one more, same thing. So whatever,
Yes.
if the difference is n lambda naught, what is the idea? They will coincide in the same phase, which means it will give you maxima. So whenever the number is integer, you will always get the maxima, right? Hello, hello.
Yes. Sir.
So n will be 1, 2, 3, and so on. Can you take 0?
And they are the same thing, right?
No,
Not
can we take
fair.
0? Is it possible to divide these two number and get 0?
No, because
No.
you already know the path is
Yeah. So 0 difference is not possible, right? So the
not at the
minimum
center.
possible is
Not
one
at the
wavelength.
center.
Yeah, at the center we can't have 0. So minimum possible is one wavelength, right? Hello, hello, yes or no?
Yes, sir. One.
Now the difference, the count difference is called order of fringe. So if the difference is 1, we call the center will have the first order maximum. If the difference comes out with 2, we say second order maximum. 3, then third order. If the center will have the higher order, so where is the 0 order? Can you guess? Is it above the center or below the center? So which point on the screen will have exactly same path length optically or equal
Above.
number of wavelengths? Above or below?
Above.
Very good. That's logical.
Yeah, because the optical path length is already greater. So the best you
So
can do is shorten the optical path
yeah,
length.
so we need to decrease it so that the extra addition will make it equal. So where we will get the 0 order? Somewhere here. So this, if this is the 0 order, which means optically both paths are equal at this point. Hello, hello, hello. Yes or no?
Yes.
Yes, sir.
So how to get the H, why not? So you know how to get the y naught, right?
So here will the theta thing work because we have like where do we add the extra length here?
The now extra length you will add in the numerator only, no? So the upper length actual plus mu minus 150 is the extra length, right? And that will be question. So look at this. What is the path difference without the extra length? Imagine there is nothing, no medium. What is the extra length? We know this is answer is d sin theta.
D sin theta.
P, sir.
So the below is extra by d sin theta because this is equal. So no need to think about left side. On the right hand side, the lower path is geometrically bigger.
Yes.
By what value?
20.
The lower path is bigger than the upper path by what value? D sin theta. And upper is optically bigger by?
Mu
minus
minus.
1.
If both are same, then there is no difference.
Yes.
Yes.
So we can say dy naught by capital D equals to mu minus 1 t, right? Over. Because we cannot sin into tan theta, and tan theta equals to opposite upon base.
Yes.
This is
Sir.
D. So you can solve any question of wave optics logically without using formula. Do you realize this?
Yes, sir.
So the 0 order has shifted upward by what value?
D by D mu minus 20.
So this is called shift of fringe pattern. So if you have used projector, so you can see projector will project a particular area, right? So if you turn the projector, then what do you see? The entire light area will move up and down as a whole, right? If you tilt the projector, what do you see? Imagine the wall is in front of you. So if the wall distance is fixed from the projector, then the overall light area will be fixed also.
Yes.
So by tilting the projector, what we can do? We can only shift the light area on the wall. Can we change the size of the area?
No.
Similarly, when you put a lens, so the G order will go up, means the entire fringe pattern which you made on the screen, that entire as a whole will shift upward. But that will not change the count of the number of fringes. So count of the number of fringes remains same,
Constant.
constant. Okay. But anyway, let's go back to the ray optics.
Sir,
Yeah.
can we do diffraction too?
So diffraction is a
I
one
got the
step ahead.
PDF that like of the updated syllabus
Mhm.
2021 versus 2023. They added all that diffraction and all.
And what else?
1 second, I'll exactly show you what has been
Say in a
added.
group, no? Say in a group.
Okay. So diffraction due to a single slit, polarization of light, plane polarized light, Brewster's law, and Polaroids. This has been added. 1 second, I'll share the
This
PDF.
we have studied all of these, right? No. Okay, don't worry. Then we'll study. It's a very small topic. The all topic will take only one class.
Sir, I've sent it on the group.
Yeah. No, I'll cover all of this. No tension. Hmm. So what is the fundamental theorem of algebra? So that is the math syllabus. Anyway. Okay. Coming to the array optics. We'll come to that one by one. Tell me. The first thing we study is reflection.
Yes.
So we know what is reflection, and the bouncing back of light after hitting the interface into the same medium, right? So the first thing you study is called plane mirror, right? Now I will not teach you the law of reflection. So let's say we have 2 points A and B, and a light has to go from A to B. So in how many ways it can go from A to B? So one is the direct way. The light can go from A to B like this, yes or no?
Yes.
And the other way is you hit the surface
Yes.
and then you go. But to hit the surface and you go B at point B, how many paths are possible? How many paths are possible? Tell me. The other way
Infinite.
will have how many paths? Infinite paths. Then what light will choose?
The path which takes the least time.
The path which takes the least time. So what we call?
Fermat's principle of least time.
So when you draw a line in which the I and R are equal, by default follows the same edge. And we can prove by the calculus or maybe by the Huygens principle. So let's say we don't know what is this. Light is coming like this and going like this. And I want to prove that I equals to R. So what I'll do is I'll drop a perpendicular from here. Because you're traveling the same medium, so speed throughout the journey remains same. So it could be V, it could be C, depending on it's a medium or air or vacuum. And because I don't know what is this, I could X, let's say this is D minus X, because the entire length I'm taking is D. So how much time it will take to go from A to B? So AO upon, which is same as AO plus, okay, anyway. So V is constant. What is AO, by the way? What is AO? Hello. What is AO? Am I audible? Hello. Am I audible, guys?
Yes, sir.
Yes.
Yes, sir.
What is AO?
X by constant. H by sin. H1 by
Sine.
sin. Okay.
So minimizing the time is as good as minimizing the VT, which is called optical length. So VT is the optical length. So you're trying to minimize the optical length, which is as good as saying minimizing the time. Both are same. So if you minimize the time, you will also minimize the optical length, but that is not required here in this case because medium is same. So we simply minimize the time. So for E minimum, what we do, if it is a function of X, so you must differentiate and equal to 0. Hello, yes or no?
Yes.
Yes.
Sir.
So I hope you all know the differentiation. If you differentiate and equal to 0, what relation do you get? I know none of you will differentiate. Are you differentiating?
Just a second.
Are you guys differentiating? Yes or no?
Yes. Sir.
Yes.
Yeah. So differentiate and tell me the answer. After differentiation, what you are getting?
X by under root h1 square plus x square is equal to x minus d minus x upon H2 square plus D minus X whole square.
This must give you answer x upon and if you look carefully, the value of sin I is the same. Sin I is this upon this.
Yes.
So law of reflection is a consequence of minimum time or minimum optical path length. So it will choose the path length which is optically minimum. Luckily here we have only one medium. So making something optically minimum or geometrically minimum will be same. But when we have multiple medium, then we have to strictly make the optical path length minimum or time minimum. Both are same thing. The entire theory of light, the ray optics, is based on this simple Fermat's principle. Is this clear?
Yes, sir.
Imagine you want to prove the law of refraction. So we have two medium. And there are 2 points which are geometrically this much away. And you want to go from A to B in the minimum time. And this is the mu1, this is mu2. So you want to minimize the time, not the length, right? Or you want to minimize the optical length, not the. So if I take this as X, and in fact, this is easy because if I take exactly this path, so you know if this is D, so if I take X, this will become, and it will come, it will also come to me logically that this is not going to give you the minimum optical length. Now let's say if I assume mu2 is denser than mu1, then this length is optically much bigger than its actual value.
Yes.
And this is much bigger than its geometrical value. And because mu2 is more, so we want to minimize the length, which means I should decrease this length somehow, right? And that is only possible if the light will travel more in the rarer medium and less in the denser. And if you do so, you will see the law of reflection automatically manifesting itself. So now to prove that this is the minimum time scenario, you can do the same thing. You can assume X up to here. This is how much. So how to add the time taken? If you want to add in terms of time, the T is how much? So the time is you travel A to O with what speed? V1. And O to B with what speed? V2, because you have different speed in a different medium, right?
Yes, sir.
So what is AO? We know the AO value, same as before. Now what is OB?
Yes, sir. It's too.
And if I differentiate again, and if I equate to 0, what we get is sin R by V1 equals to. Because earlier V1 V2 was same, it would not cancel, but now it will not cancel, right? And if I multiply both sides with C, this take the shape of the Snell's law. So Snell's law is the consequence of the minimum time condition or minimum optical length condition. If you think in terms of optical length, I can write mu1 times AO plus mu2 times OB. And now I want to minimize this optical length because optical length is mu times geometrical length. So we'll write mu1 into and if you differentiate this L optical length by time to minimize it, you will get which is exactly is this clear?
Yes, sir.
Which means every law of reflection or refraction follows the optical pathway. So when you have a lens, let's say you have a convex lens. So the light ray which goes along the center will travel maximum through the medium, right? Because of the thickness, right? Hello, 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 hello. Am I audible, guys?
Yes, sir.
Yes, sir.
So whenever a light ray enters a lens, so center is very thick, right? And therefore you travel more here. So you travel a bigger optical length here, right? And let's say you converge at a focus. So you travel a bigger optical length and a small geometrical length and you reach here. The light traveling somewhere here, assuming it is still paraxial, will travel lesser value here and will travel more here. And the light traveling below will travel less here and more here. But every light will travel equal optical length as a whole. So the total length, all are optically equal. That's why they come at one point. So whenever a light converges or diverges, they do so in order to equate the optical length which they travel individually. Now, in case of lens, it is not possible if I take the marginal rays. So we make sure that everything is paraxial, which means every ray which I have drawn is almost touching the axis, although I have shown it far away for the sake of illustration. Hello, hello, hello.
Yes, sir.
So imagine if I give you not a lens, but a disc of very small thickness. It is transparent disc. It's very thin, as you can see. But if you look from sideways, it will look like a rectangle, right? Hello, hello.
Yes, sir. Yes, sir.
Now this is the axis of the disc. I want this disc to behave as a converging lens. And therefore, what I do is, as we go away from the axis, let's say if we move away from the axis, I start changing the mu value. And I want this lens, this to behave as a lens of focal length f from the surface. So what I want is that all light ray coming parallel to the principal axis or this axis of the disk, no matter how high it is hitting. It should travel like this and converge where? So for this disk to behave like this, how the mu must vary radially. So I want to find the mu value, which is varying as per the function of radius. So how we must vary for the light ray to converge at a distance f from the surface. So we have to use the Fermat's principle, which says that up to this point all are traveling equal. So there is
Yes.
no optical difference, right? But the ray hitting the upper part is traveling more in the geometrical medium in the air. So because this is larger value, this must be small value optically to equate this value and this value. Does it make some sense to you?
Yes, sir.
So if I make this as, let's say, thickness as D, and D is very, very small than R, and it's very thin actually. So that we can assume the bending inside the disk almost negligible. So most of the bending will happen outside. So tell me, what is AA dash optically? So optically A dash is how much? Mu of that height into A dash is the optical length. Am I right? So for this ray, what is the optical length overall? Mu at a height R into A dash plus A dash F
Yes.
is the optical length. The other we can take is the central one. So center will have, let's say mu at the center is mu naught because that's the center. So what is the optical length at the center?
Mu not over
Hello.
dash. O
Plus,
dash F.
plus F only, the value is given F.
Ha.
So if you look carefully, what is A dash D? What is A dash F?
F square plus R square under root.
What is O dash D? So what is mu R D equals to? So what is mu R actually? Assuming F to be much larger than R, we can use the binomial approximation. I hope you know the binomial approximation.
Yes, sir.
I can take F common. 1 plus R square by F square power. So the mu as a function of R comes out to how much? Mu naught. The answer is mu naught minus R square by 2FD. Hello, hello, hello. So what does it mean? As you go up, the mu must decrease.
Yes.
And that's logical because if as you go up, mu will decrease. So,
Yeah, the optical path length of the lens will decrease
so
to
it will
compensate for
actually, it will take a shape of convection. Because this length is optically small, smaller, 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 and so on. Correct? So this entire disc will take a shape of optically a lens only. Convex lens. Do you realize this? Hello, hello. It is clear? So this you may expect in the J advance. I mean, they may create a definition of optical length. In fact, you should, because now they're asking the optical length a lot. So this may be the next question. So similar to this, you may expect. Okay. So this is all about the Fermat's principle and its application in all chapters. So we have seen the idea of optical length is not only for wave optics, it is also for ray optics. And every light phenomena is indirectly governed by the Fermat's principle, whether you study or not, doesn't matter. So we do have alternative way of studying, but this is the real cause. Okay. Now, what I'll do next is I'm going to derive all the formula in each and every topic, and then I'll come to the question one by one. So first, we'll start with the plane mirror. In plane mirror, do we have any formula?
No.
Yes. Only one
mean,
formula.
only one,
the angle
yes.
between the mirror, right?
Ah.
So if we have two mirrors, okay, anyway, we'll talk about something quickly. If a light ray is hitting like this, okay, at angle I, it will go back by same angle I. So the first question you need to know is what is deviation? So deviation is the angle by which you must rotate the reflected ray to become parallel to the incident ray. Or the other way of thinking is you must, if the initial path of the ray is like this, and this is the final path, then the ray has turned by this angle. So how much is deviation here? So every plane mirror will turn the ray by pi minus 2i. And what is the sense of rotation here? Anti-clockwise. Hello, hello. Clear?
Yes, sir.
Yes.
Yes.
So when a light ray is coming like this, so if this is normal, so what is the total deviation here? When we suffer multiple reflection, then we have to add all deviation to get the total deviation. But when you add all deviation, you need to check the rotational direction. So are all deviation in the same sense? Are all deviation in the same sense? Yes or no?
Yes.
So it is
Yes.
clockwise. So we have to
See,
just add
first
the
one is clockwise and next one is also clockwise.
we just add this. So pi minus 12 plus pi minus 2 beta. Is this clear? What if I change the so in this case, the turning is like this, but the next turning is so you extend the incident ray and then you turn towards the reflected ray. You can see we have two different sense of rotation. So what is the net deviation? So in such case, you have to choose one of them as positive, other as negative. So you can choose clockwise as positive, then anti-clockwise becomes negative or vice versa. But it doesn't matter because if you choose something as positive and if the final answer is negative, it means the deviation is other way around. Hello, hello. Clear?
Yes. Yes, yes. So we have to subtract this, right?
So we have to
And
subtract.
if we take row 1 first, the delta 1 first, then clockwise we'll get division.
Yeah, so if I'm taking delta 1 and
Ah.
then delta 2, and if the answer is positive, means delta 1 clockwise is the answer. And if I do something like this without any modulus, and if I get negative answer, it means it is anti-clockwise. Okay. It's clear? It is clear, huh?
Yes, sir.
Here,
Okay. Keep on saying something. Yeah. Come on. So the definition is a very interesting concept. Let's say if we have two mirrors, so a ray of light is coming, hitting the first mirror, then getting reflected, hitting the second mirror, and then getting reflected back. So it is exactly suffering two reflection. Question is, if the total deviation suffered by the ray is equals to the angle between the mirror, what is the angle? Question is clear?
Yes.
So find theta.
okay.
Yeah, that's correct. So the answer is 120 degree. So alpha alpha, beta beta. So what is the net deviation here? But if you look carefully, this is 90 minus alpha, this is, and the sum of these three is 180.
So actually we can directly use 360 minus 2 theta, right?
This becomes 360 minus 2 theta is theta. So theta is
120. Because we know that deviation is always 360 minus 2 theta, right?
how in.
No, it is for generalized case, right? For any theta,
Yeah.
deviation is 360 minus 3 theta, right?
No. If I'm taking only two reflection, what if I take three reflection?
No, no, I'm talking about only 2 reflections. So then we have to solve only, right? If there are more reflections, they say.
So the next question is, so we have two mirrors. A ray of light is coming parallel to one of the mirror. So I'm taking the base parallel to base. So now this is also alpha, right? So it suffers n reflection, which we don't know. It suffers n reflection and then retraces the path. After n reflection, it retraces the path. If n alpha equals to some constant c, find c. And given alpha, maybe I can make it 15.
Sir, what is that? N alpha is equal to C.
Constant.
Okay.
So find the constant c actually.
Alpha is 50 or 15?
15, 1 5.
1 5. Okay. Okay. to check.
No. 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 That's not correct. Send me your solution. I would like to see what you did. That's correct. But I think you have guessed right. Huh?
No, I studied optics, so I know this method.
So what is the condition for retracing the path?
It should be incident normal onto a mirror, any one mirror.
Yeah. So let's say I consider this reflecting like this. It's two gross, but let me
150
take it.
degrees.
So this is alpha, this is also alpha.
Yes.
Now, if this is alpha, this is alpha, this is 2 alpha.
Hmm.
So after second reflection, this 2 alpha, after third, it will be
3 alpha.
this is 3. So
6
till it becomes
alpha.
90. So if it
Six
is happening after n,
reflections.
so n alpha must be 90. Then only it is possible, right?
Yes.
Hello, it is clear? Yeah.
Yes, yes.
Yes. Got it.
Yes. So only when n alpha becomes 90, it is going to retest. And therefore, alpha given 15. N is 6. I hope this is clear.
Yes, sir.
So the next concept is so plane mirror is the only
there-
difficult part.
For the method of, there was a better method to do that.
Yeah, tell me.
Like we could take the image of the mirror itself.
Yeah, correct. So that is the called if I want to find the minimum separation I can reach to the mirror, then we use that.
Which one? Sorry, I didn't know
Let's say
that.
if I want to know what is the nearest separation, what is this value, x minimum? And given, okay, let's say it is known to you that this is D or L.
Hmm.
Then tell me, what is the x minimum?
L cos n minus 1 alpha.
L cos
N minus 1 alpha.
minus 1. L cos, what is it? L cos
L
alpha,
cos n minus 1 alpha.
like this, no?
Yes.
Yeah. So you can keep on taking the reflection till the light becomes perpendicular. So you can just extend this line. You can extend this line.
We'll take the image of the mirror itself.
Yeah. So how many images we have to take?
N. No, एक second. N or n minus 1.
Till this light ray and this mirror becomes
Perpendicular.
so. So this is alpha given, and this is also alpha, and this is L given. So the minimum distance is this is x. Actually, this x will come here actually. So it becomes L sin alpha. So n will not come.
Ah,
Okay.
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 Yes.
Anyway, so next. The next part is what is the effect of rotation of mirror?
Sir, actually the answer is the same only because n alpha is 90. So L cos n
Yeah.
minus 1 alpha is just cos 90 minus alpha.
Correct. That's true. So effect of rotation of mirror on a reflected ray. I hope you all remember this. So if we have a mirror, and if it is, let's say if the ray is coming exactly at the right angle, so it is the normal incidence. How the light will reflect back onto the same line? So the reflected ray is going this way. So what you do next is you turn the mirror, right? And if you turn the mirror, by theta, the normal will shift like this, right? And the new normal to the mirror will also turn by theta. So same incident ray will go at this angle, theta again. Hello, yes or no? So
Yes.
how much reflected light turned?
2 theta.
So when you turn the mirror by theta, the reflected light will turn by 2 theta, and that too in the same sense, right?
Yes.
So if I want to take a light ray here, how we keep the mirror to turn by 90?
It will be 45 anti-clockwise, right?
Clockwise, no?
No, we are our it is turning 90 degrees anti-clockwise,
Yeah,
right?
anti-clockwise, correct.
So
So
mirror
this
has to
angle
turn
will be
45 clockwise.
40.
Anti-clockwise side.
Yeah, because the mirror was actually like this in the beginning.
Yes. This
To
was the
turn
first
the
question I asked.
to turn the reflected ray this way, I must turn by half the angle this way. So I must turn the mirror by 45. So what you are supposed to do is imagine a mirror normal to the incident ray and then check how much you need to turn to get the new direction. Clear? Yeah, just you were saying something. What you said? What you said? Hello. Hello, Josh. Are you there?
Yes, sir.
What you said? So this is how we perform the magic, right? So to create a virtual person on a stage,
45.
yeah. So the actual person is somewhere else. What you see is the image of the person, and you think that it's a real. And they take a sword and cut through the person, right? So if I keep a mirror exactly at 45, and another here exactly 45. So any ray traveling,
More mirrors would be required, right? Both sides.
yeah, I put it one. And then
One above.
So this is like a kaleidoscope, right?
pardon?
This is like kaleidoscope now.
Yeah.
Using
This is like a, you can say, periscope also.
But kaleidoscope, but we use only 2 of them, right?
Yeah, it's called periscope basically. Periscope.
Submarine we use.
Yeah. Now imagine there is an object like this, of this orientation. What is the orientation of the image as seen by mirror 1, mirror A, mirror B, mirror C, mirror D? So the line of symmetry of the first mirror is like this. So image will be symmetrical to this line actually. And to understand this, you can draw a line like this. And you can just draw the same line here. So this line is how much? 45. So it will look like this actually. So the image here will be horizontal, left. So the first mirror will form something like this. Then how the second will form? Back to the same. Like this, right? Like if you take the reflection by the same parallel mirror, it will go back here, no? Hello, hello, hello. Then C will form what? This is A, this is B. What C will form?
A mirror image of A.
It will form left, right actually.
Yeah.
And D will form
Opposite of B.
Hmm?
45.
downward or upward.
Down.
Because this is the mirror, no? It will form again back
B,
to
I
same.
think we missed B mirror, right?
No, B mirror we haven't missed. This is B.
So our initial is A.
This is A. This is actual. This is also B also. Actual A, again B, again C, and again it will become A only.
See, after A reflection, it will be 90 degrees turned anti-clockwise.
Yes.
After B, it will be 180 degrees anti-clockwise.
This is actual.
This is actually after A, it will be towards left. Then after B, downwards.
No, after B it is again upward.
How upwards? Correct, 45. Understand.
And then right,
Huh.
and then upward.
Yes.
How many of you are able to understand this? Tell me.
Understand.
Is this clear to all of you?
So just a
Yes.
second.
We can just go on checking net deviation, right?
Yeah.
Whenever net deviation is 0, we will get the same object.
Yes.
Yes, I got it.
So now this idea of rotation of mirror and effect on the reflected will have some questions. So there is a mirror which is pivoted at the center and it is rotating with angles with omega all the time. And what I'm drawing is the snapshot. There is a wall. The distance between the pivot and the wall is D. So we have a flashlight or a torch, you can say. Which is directing its beam towards the pivot all the time, no matter how is the mirror. If at an instant when the mirror is in horizontal position, the angle that the mirror normal and the flash light makes theta equals to 60 degree. The reflected light will go somewhere here, right? And because the mirror is rotating, so this light ray will keep on sliding on the wall like a spot. So this spot will try to go down or up at this instant. At a very next moment, the mirror will turn by d theta.
Yes, and the total angle will also turn by 2d theta.
The
So
question
down.
is, what is the velocity of the spot? Solve it. At this particular instant.
So 2D omega cosec square theta.
2D
Yeah.
omega.
Cosec square theta.
Yeah, just what's your answer?
Yeah, D cosec square 60 degrees into d theta by that is d theta is that so 2 omega d cosec square 60 degree.
The same answer, right?
Correct. That is for any instant, but you said at that instance we need to substitute theta 60.
Yes, sir.
We can write that as d cot theta and then differentiate it.
Yeah, you can also simply say x, and you can take from this line, you can say this is alpha.
Sir, I got
So-
d6 square theta into 2 omega.
Yeah, I think that is correct. So what is tan alpha?
X by d.
Tan alpha is, what is x?
D
So what is
tan
dx or dt?
D. Yes, but alpha we can substitute as 90 minus theta.
Yeah, at that one. So sec 90 theta will become what?
2 times d theta by dt, right? D alpha by dt is
Yeah, that is, this is 2 omega.
2 omega. Yes.
If the mirror is turning at omega, then alpha which is at 2 omega. So we know that this is, so okay, what is d? What is sec square alpha? Sec square 90 theta, this becomes 2 omega. So sec square 90 theta is what? Cosec only.
Cosec square.
So this answer is correct. This is correct. So if you're taking the sec, then it become alpha, right?
Yes.
Okay, very good. Is this clear to all of you guys?
Yes, sir.
The next part is size of mirror. You see yourself. So what is the minimum size of mirror to see yourself completely? So on the wall, which I'm not showing, and let's say this is you, this is your head, this is your foot. But how we see? We see only at the eye level. When the light enters the eye, we see, right? So for the sake of drawing, I'm drawing the eye level somewhere here below the head, right? So how you will see yourself completely? When the light from the foot and the head will reach the eye? Hello guys, yes or no?
Yes.
Yes, sir.
So the light traveling from the head must hit symmetrically to reach here,
I and from foot also.
and same is from foot also. The light traveling from here. So where we should keep the mirror to get this answer?
Between those 2 points.
So it is the mid of the eye and head level,
Yes.
and mid of the eye
Foot
in the
level.
foot level, right?
Yes.
So the diagram is not correct, but this is. So if this is x, this is x, this is y, then this is also y. As per
So
the law of
half
reflection.
length.
So half length is not sufficient. Half length at this position, right?
At that position, yes.
So we can say 2x plus 2y is the overall height of the person. So x plus y is. Okay.
But that also at a particular position, right?
This is what I said, no?
Ah.
So why are you repeating? Okay, anyway. Now, what if I take the half size but don't place like this? So imagine if there's a person of height h. And we have a mirror exactly of half height, but kept in a way showing the figure. It is exactly half. So what part of your length of the body you can see? How much you can see? Oh, I need to mention the eye level also. Right? So let's say eye level is h by 10. Then how much you can see?
That is unnecessary. 9h by 10.
Everything except the bottom one thing.
Bottom
9h by
110.
10.
Hmm. So you can see
Total
the
we can-
top. Yeah, you can see the top with ease.
Yes.
Same value.
We can just
What-
take extreme values, right?
Yeah, I think we'll take it. So we know the length, right?
Yes.
H by 10 minus h by 2.
4h by 10.
So the difference, double of that, you can see below, right?
8h by 10 plus h by 10 above 1.
You can see h by 10 for sure, plus h by 2 minus h by 10, 2 times, right?
Yes.
It's clear. I think this is correct now. So what is the answer? H minus
9h by 10.
h by 10 only. 9. So whatever is this length, you can see the twice of this value below and the above all value. So you can see only 9 h by 10, which means any mirror which is this part. So any mirror which is above this point, the twice of that value we can't see, right? From the any mirror, you can get this
Yeah.
answer. The next question. Let's say there is a mirror of length L. This is surface. If I put point light source anywhere on the surface, and if I take the only reflected light, so the extreme will be like this only. The question is, what is this length? And does it depend on the height of the mirror from the surface? Yes or no? So the light falling after reflection is which area you can see? What is X?
12
Very good.
and independent of height.
That's very good. Man.
What I did, I took object distance from starting point is x, or K, because you already took X.
This is also L1.
L1, so that one will also be L1. And now we can take that one as L1 plus capital L. So that one will also be L1 plus capital, and now subtract the two.
So you have to separate the twice of L1 plus L minus 2L1, right?
Yes. So we
Yeah.
get answer as 2L independent of height.
So the answer is independent of height. That's very interesting. So no matter where it is the same height, right? Okay. So if I say the height as Y, and if the mirror is free falling, so at initial height, let's say the height is Y, and let's say you drop from height H. So the mirror is dropped from height H. Okay. So at some instant when Y is H by 2, at what speed the flash, this spot will recede away? Or you can say at what speed this point A will go away? Because as the mirror will come down, the length remains same, but as a whole it will shift, right? Hello. As I
Yes.
draw the mirror, below, the same spot will form far away. Yes or no?
Yes.
So if it is free falling from the height capital H, at the time when the height is H by 2, what is the speed of the spot?
Speed of the spot.
See,
Stationary,
speed of the spot is same as speed of A.
Yeah, that will be stationary, right?
No. The length is fixed. No, why it is stationary? What if I draw the mirror here?
But then length will be fixed.
But
Okay,
not the
understood
position.
what you're saying. Ha.
It will come here, right?
Yes. Understood.
So it is shifting as it is coming down.
Uh-huh.
It is shifting, right? The length is constant, but the shifting will happen, right? So
Yes.
At the instant when Y is H by 2, what is the speed of A? And I'm releasing from rest at height H. So when the height of the mirror is H, the speed is 0 of the mirror. But as it comes at H by 2, it will have some velocity. And the spot will be moving towards the right with some speed. What is the speed of the spot? Is my question clear?
Yes, sir.
Yes.
See, I have a doubt in this question. See, our distance is not changing, right?
The length of the spot is not changing.
Then how will the point move? Because let's say if I draw a ray, which is at a distance L1 in the initial case,
The
like
source
this,
is fixed. Source is fixed, no?
the source is fixed, but L1 won't change, right? Whether it falls down or it doesn't fall down. Hello. L1 will be constant at any instant, right?
L1 is constant. Let me just check. So if I draw a light ray like this,
It will fall at point A only.
yeah, yes.
So it will be stationary only, right?
Yes, it is going to be stationary only. Correct. The velocity of A becomes
Zero.
0 then. Yeah, that's true. No matter
That's
how
what
it is
I was
falling,
trying to say.
because source is fixed, it will remain same.
It will happen if there is a horizontal velocity.
Yeah, correct. So now that will lead to the second question. If we have a screen like this, vertical screen, and let's say we have a, what do we have? A mirror. A mirror of length L. And now the distance between the so now imagine we have a source of light, and this height is y, and this height is let's say h1. So the source of light is here. What is the length of the light on the screen after reflection? Not before. So light will go up to which point on the screen? So if you take the extreme light, it will go from here to somewhere here, right?
Yes.
Yes.
Question is, what is this length? So given L and the height ratio y h1, what is this L? This L dash. So no need to solve, but you can solve it. So actually you can take the mirror image of the source, right? Which is actually the extension of this lines backward, right?
Yes.
Technically it's not the right diagram, but anyway, you can understand what I'm saying.
Right.
Just take the mirror image here. But once you take the mirror image, it is easy for you. Apply the similar triangle, right? So this L by Y is same as,
L dash by h plus y.
that's it. So L dash is h by y plus 1 into L. I hope this is clear.
Yes, sir.
Okay. So you can solve any question now. I can differentiate and integrate something. Let's say source is moving, then why we change, then we can do actually a lot of other things. Okay. So whenever you have the mirror question with point source, just take the reflection and just apply the similar triangle to get the answer. Okay. So then we have something called what we left in mirror? In mirror? Image formation. I hope you know the image formation.
और dead zone वाला.
No, that's image formation. Number of images, I'll just tell you at the end. So if the object position's coordinate is given to you,
Okay. We can
And
use that
equal-
perpendicular line one formula, right?
yeah. So we can find the coordinate of the image.
Yes, correct.
So in maths, you learn some direct formula, or you can derive it in basic.
Yes, we can derive it using that perpendicular line we can form and distance formula.
The
or
midpoint
we can
formula.
derive-
The
or also
midpoint
the
will lie
midpoint
on the
formula.
mirror
Yes.
equation.
Ah,
So the midpoint should satisfy this point, this equation, and then
yes.
the slope of the two lines are mutually proportional to -1, right? M1 and 2. Or you can use mathematics and derivation directly. It's the same thing. Okay. The next idea is angle between mirror formula. So only remember for the simple answer. So if the angle is theta, if you extend the line, you fall in the dead zone, right? So when two mirrors are parallel to each other, do we have any dead zone? So there is no dead zone, right?
Yes.
So what you get is infinite image. And you can use the crisscross method. So the first image from M1 is A distance away on the left, and M2 it is B, and then you can do the crisscross. You add the separation here, then you get 2A plus B. And then A plus 2B, then keep on doing this. Add A plus B again further. 3A plus 2B. And then 2A plus 2B. 3B. And keep on doing till you get the infinity. So whatever number you want, you can get the answer. For this situation, we know, first of all, we find the M value. So we have space here. So first you find this value, and then what you check? If M is even, then no matter where is the object, whether it is on the angle bisector or is it not on the bisector, for even case, the number of images we have to make M minus 1. Because even is only possible when the last image will coincide. Okay, so then the last image will coincide, then you can separate the one because two images are superimposed. When M is odd, there are two choices. Angle bisector, symmetry will coincide the last image. That's why N equals to not on bisector. Answer is same as it. If M is fraction, what's the answer? So the rule says write M as 2 into integer plus minus a deviation, or this must be fraction value. So you have to write 2 integer plus minus fraction. So you can use plus also, minus also, and the answer will be 2y. Clear? So when you're getting a fractional number, let's say you're getting something like 5.3. What's the answer? So 5.3 we can write as 5 plus 0.3, right? Oh, this should be fraction, means less than 0.5 actually, less than 0.5. Yeah, that's very clear. But what if the answer is 5.8? So if it is 5.8, then
6 minus 0.5.
so we have to take the number of images 6, not 5. So we basically the idea is take the nearest integer.
But number of complete images will be 5 only.
No. In the dead zone, we don't count. Actually, this part is actually not taken into consideration. All the books written in this topic is wrong only. So generally, the idea of solving is we write 2i plus minus delta, and delta must be the. So we have tried it. Okay, sorry, my bad. This is all no. What I was saying correctly. Just a moment. We have tried even number plus minus delta. So your answer is always even number. My bad. So when I answer is 5.3, how to write as even number? So you can't write 5 because this is odd number. So to write as an even number, we have to write 6 minus 0.7, right? Because the formula is 2i plus minus delta. So the number must be even. So the answer is 6 here. But what if I have 6.3? Then 6 is the answer. What if I have 10.3? 8 answer. 9.3? 9 answer. Understood what I'm saying? So it is 2i plus minus delta. I means, so 2i becomes what? Even number. So fractional part is very controversial.
9.3 will be 10. Huh?
9.3 will be 9. Sorry, 10 actually. My bad. 10. So, but anyway, they will not ask you the complex part because that is controversial. In some case, that may be very complex also. So, leave it. And this is actually only true when the object is kept at angle bisector. I mean, there are so many conditions for this. That's why this part is not taught, and all the books, whatever written so far, all the Indian books and all the booklet packages, they have not mentioned this part clearly. What they mention is wrong. So no need to worry. So this is how we end the plane mirror. Next class, I will finish the rest of the part, the curve mirror and so many other things. Okay. But I think you have got the base. Now you can study how to do the light ray and all. So try to study from notes and try to understand as much as possible. But I'll cover some of the important concepts of the curve mirror as well. Okay. All right. Bye and take care. Good night.
Bye, sir. Thank you, sir.
Bye,
Bye,
sir.
Shivam.